digital communication in our digital manufacturing course. So till the date, we have seen integration in a digital manufacturing, how we can integrate different processes. Today we will see digital communication. So I'm sharing a screen with you. So you can see here. So the digital communication and technologies for digital manufacturing. So our today's objective is to understand what is digital communication and technologies for digital manufacturing. In this particular course, we will see the following contents. Give a minute. I will full screen this one. So now you can see it clearly. So here we will see introduction to digital communication, then digital communication block diagram, then transparent machines in a digital manufacturing, interconnected objects in a digital manufacturing, industry uses of interconnected objects, industry uses of transparent machines, real-time uses of digital manufacturing in industry,
मदन सर,
digital.
सॉरी टू
Yes,
इंटरप्ट यू
sir.
हियर.
Yes,
आपने
sir.
मुझे कॉल किया था. आई कुड नॉट पिक अप द कॉल. एग्जाम्स आर एक्चुअली हैपनिंग.
Okay, sir. Okay. So just I want to inform you I'm starting the session.
राइट राइट
That's
सर, प्लीज गो अहेड सर, प्लीज गो अहेड. ओके,
okay. Okay.
फाइन
Thank
सर.
you, sir. Thank you. So industry uses of interconnected objects, industry uses of transparent machine, real-time uses of digital manufacturing in industry, digital thread, industrial internet of things for digital manufacturing, industrial internet of things components for digital manufacturing, big data for digital manufacturing, process of big data collection in digital manufacturing. Case study, Bosch, Smart Factory, Rolls-Royce, Intelligent Engine. So let us start with the introduction to digital communication. So what is a digital communication and how we can achieve digital communication? That is the first thing that we will answer today. And we will start simultaneously how we can go ahead with the digital communication. So the interconnected objects in digital manufacturing refer to network devices. So with the help of network, we can connect devices, machines, and systems that communicate and collaborate with each other within a manufacturing environment. So we are having various devices, small devices like sensors. They are connected with machines, and machines are connected with systems. So they are interconnected with each other, so that and they are communicating and collaborating with each other within the manufacturing environment. So that is nothing but a digital communication. So they are communicating with each other through some particular medium. So medium means network is there. Through a sensor, we are taking the data from the devices through the machines, and we are transferring it to the systems. So these interconnected objects form the backbone of the industrial Internet of Things. So when we say they are interconnected, they are communicating with each other, they are receiving and they are sending command to each other. So that is nothing but industrial Internet of Things in digital manufacturing. So enabling seamless data exchange, automation, and optimization of production processes. So it enables data exchange from the real-time situation. It also helps in automation. So remotely we can give instruction, or that particular machine can works on its own with the help of programs, and optimization of production processes. So while doing this process, it will optimize its parameter in order to achieve maximum performance. So that it can do. So this is the advantage of digital communication. So hence are some example of interconnected objects in digital manufacturing. So here we will see some example of interconnected objects. So how we can interconnect the objects in a digital manufacturing. So first is the sensors and actuators. So basic component of any digital communications are, we can say, sensors, which enables us to collect the data from any particular machine, and where they will communicate. So from whom they will communicate? So actuators, with the actuators they will communicate. So actuators are the devices which enables to do a particular activity. So that means where we should communicate, to which device we should communicate. So we can say here we can communicate to the actuator. So sensors will take information from actuator, and again it will give instruction to the actuator. So these are the devices that collect data on various parameters such as temperature, pressure, vibration, and motion. So sensor provide real-time information about equipment performance, environmental conditions, and product quality, while actuators enables remote control and automation of the machinery and processes. So when we are having a data from the sensors, so we can give some instruction to the actuator, so like a feedback to the actuators, and it will do some work on that feedback. So this is the process how sensors and actuators are connected. So sensors are collecting data and actuators are working on that data. So that is the flow, how these sensors and actuators are connected. So manufacturing equipment and machinery. So machines and equipment such as CNC machines, robots, 3D printers, and assembly lines are interconnected to share data and instructions. So machines and equipment such as CNC machines, robots, 3D printers, and assembly lines. So these are interconnected to share data and instructions. So as I have explained you, there are the machines and equipment like CNC machines are there, robots are there, and 3D printers are there, and assembly lines are there. They are interconnected and they share data and instruction with each other. So this connectivity allows for coordinated operation, predictive maintenance, and optimization of production workflows. So when we say connectivity between these machines, robots, so when I say a CNC machine is creating a product, so automatically robots will come there and it will take that product to further operation, further process. So we can say like that. And when we see 3D printer is again in that particular workflow, then the product developed in a 3D printer, it gets shifted for the machining purpose to the CNC machine. CNC machine will process it, it will machine it, and further it will go to the work table. So that is the process. So here we can say manufacturing equipment or machinery are interconnected and they share the data and instruction with each other. So means 3D printer will communicate that this particular product is completed, you can carry it to the next machine. Then this particular product is finished, you can carry it to the next machine. So this connectivity allows for the coordinated operation, so predictive maintenance and optimization of production workflows. So embedded systems and controllers. So embedded systems and programmable logic controllers are used to control and monitor manufacturing processes. So embedded systems, we can say electronic systems are there, and embedded systems again we can say the sensors are connected with the embedded systems, and programmable logic controller PLCs, as we know that we can do some operations on PLC, program on PLC, so that can be executed through the actuators on a real time basis, and it will perform some activity in the manufacturing environment. So the programmable logic controllers are used to control and monitor the manufacturing processes. These devices communicate with sensors, actuators, and other equipment to execute control algorithms, regulate parameters, and ensure that production processes operate efficiently and safely. So this is the embedded systems and controllers. So after looking at embedded system and controllers, so the enterprise resource planning ERP system is there. It is also contribute in a digital communication. So ERP systems integrate various business functions such as inventory management, procurement, production planning, and quality control. So interconnecting ERP system with manufacturing equipment allows for a seamless data exchange between the shop floor and the back office, enabling better coordination and decision making across the organization. So ERP is nowadays performing a better function in any organization. So there are cloud-based ERP systems. There are real-time information giving ERP systems. So this is a backbone we can say of any industry which provide information from one section to another section. So when I say I am giving some particular demand, it get recorded by the ERP system. When I say I am giving that particular demand to a shop floor, it get communicate to the machines, and that particular demand fulfillment is done by again that machines, and we can do procurement with the help of the ERP system. We can do inventory management, we can do production planning, and we can do quality control. So interconnecting ERP systems with manufacturing equipment allows for seamless data exchange between the shop floor and the back office. So when we say ERP systems with manufacturing equipment, when we are connecting these, so that allows for a seamless data exchange between the shop floor, so that is the workplace, and the back office. So management can give their decisions to the shop floor. So management can take some decision and it can instruct to the shop floor. So related to the requirement of a particular thing, and that shop floor can fulfill that requirement. So it enables a better coordination and decision making across the organization. So means working professional from the management as well as the shop floor worker are connected through the ERP system, and the management can take decision and it can communicate that decision to the shop floor. So that will give a better coordination and decision making across the organization. Then there is a digital twin technology. So digital twins are virtual representation of physical asset, processes or systems. They are interconnected with their real world counterparts and continuously updated with the data from sensors and other sources. So the next thing is the digital twin. So in a digital communication, so digital twins also perform the role of a digital communication. So digital twins are virtual representation of physical assets, processes or system. So means we can replicate physical assets, processes, or systems in a computer environment where we can see that physical world inside the computer. So they are interconnected with their real world counterparts and continuously updated with the data from the sensors and other sources. So digital twins enables manufacturer to simulate, analyze and optimize production processes in a virtual environment. So we can say that there is a real physical asset, a real physical process or real system. We can recreate that system inside the computer environment, and with the help of sensors mounted over the physical system, we can collect the real time data on the computer environment. So the sensors and other sources will give a real information of that particular physical environment on a computer. So digital twins enables manufacturer to simulate, analyze and optimize production processes in a virtual environment. So reducing the need for physical prototypes and experiment. So that will reduce a need for physical prototypes and experiments. So there is a very minimum need to invest on a physical system. So instead of creating a physical system directly, we can create a prototype of a physical system and we can experiment on it. Then we can go for a actual physical prototype. Then there is a cloud computing and edge computing. So cloud computing platforms and edge devices provide the infrastructure for storing, processing and analyzing large volumes of data generated by interconnected objects. So cloud computing and edge computing. So again, when I say I'm connecting ERP with the shop floor or ERP with the MES system. So cloud computing comes in a picture and edge computing as well. So cloud computing platforms and edge devices provide the infrastructure for storing, processing and analyzing large volumes of data generated by interconnected objects. So cloud-based services enable real-time monitoring, analytics, and collaboration across distributed manufacturing facilities, while edge computing devices process data locally to minimize latency and ensure reliability in a time-critical application. So when we say cloud-based services, so they enable real-time monitoring. So cloud-based services gives us a real-time data from the network. So it also provides some space to store the data, and we can do analytics there itself with the data and collaboration across distributed manufacturing facility. So cloud also helps in collaboration. So we can transfer data from one functionality of a manufacturing organization to other functionality of the manufacturing organization. So that we can do through the cloud based services. And then with edge computing devices process data locally to minimize latency. So when we say edge computing devices, they are nothing but sensors which are collecting the data locally. So to minimize the latency and ensure reliability in time critical applications. When I say I need a data of this particular time and this particular day, so yeah, this edge computing devices can retrieve that data, or they can give a real time data, so where we can take decision based on that data. So in this way cloud computing and edge computing help us in digital communication. So then communication protocols and standards. So interconnected objects in a digital manufacturing rely on communication protocols and standards such as MQTT, OPC and Ethernet IP to exchange the data securely and efficiently. So as we know that there are various protocols in the communication, online communication. So MQTT is one of the protocol, so which was invented by the IBM for transferring the data from one system to another or one location to another location. That was basically developed for the gas and oil industry, where they can communicate with the situation of the pipes there, location at the location to the remote office. So that was developed by the IBM machines, and we use that. Again, OPCUA is another protocol, and Ethernet IP is another protocol to exchange data securely and efficiently. So there will not be a data breach when we use these protocols. It secure the data. These protocols ensures interoperability between different devices and systems. So enabling seamless integration and collaboration in a complex manufacturing environments. Then digital communication block diagram for digital manufacturing. So then manufacturing environment is there. Then actuator network, sensor networks are there. Programmable logic control networks are there. Then manufacturing system execution networks are there. Then enterprise resource planning networks are there. Then cloud computing networks are there. So these are the various networks. When we say there is a digital communication, how it is connected. So first, manufacturing environment, that is a shop floor. So our machines are there. On a machines, we are having actuator and sensors. Then we are having programmable logic control networks. Then we are having manufacturing system execution network. Then we are having enterprise resource planning network. Then we are having cloud computing networks. In this way, we can achieve a digital communication in the digital manufacturing system. So now let us go ahead. So when we say digital communication block diagram for digital manufacturing, so the manufacturing environment, what it represents. So this represents the physical space where production processes occur. So manufacturing environment is nothing but where we are having various machines and they are working to produce something. So this is a manufacturing environment. Then sensors and actuators. Sensors gather data about various aspects of manufacturing environment, while actuators are responsible for controlling physical processes based on input from the sensor. So sensor gather sorry. Sensor gather data about the various aspects of manufacturing environment. So sensors are mounted on the machines, sensors are mounted on various systems. They gather data about various aspects of manufacturing environment, and actuators are responsible for controlling physical processes. So while actuators are there and they are responsible for controlling physical processes based on input from the sensor. So sensor gives the input, actuators work on that input. So in this way they communicate with each other. Then programmable logic controller, PLCs. PLCs are used to automate and control machinery and processes in manufacturing. So as we know, there is a cylinder and piston arrangement. So A plus, B minus, all network. We can control movement of a machine with the help of PLC controller, and we can give commands to the machine with the help of PLC controller. So this is a programmable logic control, in the sense in a timely manner a machine can execute a particular operation, so that can be done with the help of PLC controller. So the control machinery and processes in a manufacturing environment. They receive input from the sensor. So PLCs are the devices which can connect with the sensors. They receive the information from the sensor, input from the sensor. They execute control algorithm. So whatever program we have given inside the PLC, they execute that particular program and they send commands to the actuator. So in this way they are arranged one by one. So sensors are first, sensor gives input to the PLC, PLC execute the algorithm and it gives command to the actuators, and actuator perform the actual function. So in this way this programmable logic controller can communicate and it will help in a digital manufacturing. Then manufacturing execution system. So MES systems manage and monitor manufacturing processes on the shop floor. They coordinate activities such as scheduling, resource allocation, and quality control. So the MES systems manage and monitor manufacturing processes on the shop floor. So MES, we are controlling the shop floor with the help of MES. They coordinate activities such as scheduling, resource allocation, and quality control. So they coordinate activities like scheduling. So which activity will be, which activity is after which activity, so that we can do. Resource allocation we can do. So which resources are useful, and quality control we can do with the help of manufacturing execution systems. Then there is a enterprise resource planning, ERP system. So ERP systems manage business operations such as inventory management, procurement, and financials. So as I have explained, ERP is the backbone of any organization. It will communicate the requirement of management to the shop floor. So the ERP system manage business operations such as inventory management, procurement, and financials. They integrate with MES systems to ensure alignment between production activities and overall business objectives. So here we can say the MES systems to it ensures alignment between the production activity and overall business objective. So ERPs are very crucial in performing any objective of the management through the shop floor. So after that there is a cloud computing in our digital communication block diagram. So in a cloud computing platform provides storage, processing and analytics capabilities for the manufacturing data. They enable real-time monitoring, analysis and collaboration across distributed manufacturing facility. So cloud computing performs, provide, it store the data, it process the data and it performs the analytics. So that are the capabilities of the cloud computing and it perform all these activities for the manufacturing data. So they enable real-time monitoring, analysis and collaboration across distributed manufacturing facilities. So what are the transparent machine in digital manufacturing? So the next question is about the transparent machines in a digital manufacturing. So transparent machine in the context of digital manufacturing refers to machines or equipment that operate with a high degree of visibility. So where we can say a transparent machine which can be seen, which can be traced, which can be interoperable within the manufacturing ecosystem. So the high degree of visibility, traceability, and interoperability within the manufacturing ecosystem. So for the machines or equipment, so that operate with a high degree of visibility, traceability, and interoperability within the manufacturing ecosystems are the transparent machines. So these machines are designed to facilitate seamless data exchange. So these machines are useful to communicate with each other. So communication means they are transferring data with each other. So real time monitoring what is happening at that time on the manufacturing shop floor. It communicate that and transparent communication across the entire production process. So transparent communication means whatever happening there, they communicate as it is. So that is a transparent communication across the entire production process. So below are some breakdown of a key characteristics and implications of transparent machines. So first the data visibility. So what is the data visibility? So transparent machines are equipped with sensors, actuators and communication capabilities that enable real-time data capture and transmission. So what is the data visibility? So when I say transparent machines, they are equipped with the sensors, actuators, and communication capabilities that enable real-time data capture and transmission. So sensors are used to capture data from the machine. So they capture a real-time data and they transmit the data. So they provide visibility into various aspects of production. So we can see by sitting at one place what is happening in the production process. So including machine performance, how machine is performing, process parameter, what are the process parameter, values of process parameter, how they are executing. We can set some process parameter and product quality matrix and what is the output as a product and what is the quality of that product. It will create a product quality matrix. This data visibility allows operators, managers, and stakeholders to monitor production processes closely and make informed decisions based on accurate, up to date information. So, when we say this data is there, so it shows operators, managers, and stakeholders to monitor production processes closely. They monitor the production process closely and make informed decision based on accurate, up-to-date information. Then traceability and accountability. Transparent machines support traceability throughout the manufacturing processes, enabling the tracking of raw materials, components, and products at each stage of production. So transparent machines also support traceability. So we can check where is that particular product. We can trace the location of the product. We can trace the location of the process. throughout the manufacturing process. It enable to track the raw material. It enable to track the components. It enable to track the products at each stage of production. So by recording and documenting data related to production activities, transparent machines facilitate accountability and quality control. So by tracking all these step by step, it facilitate accountability and quality control. So helping to identify and address issues such as defects, errors, or deviation from the specification. So traceability and accountability basically helps us to track the defects in the product. Whatever errors, manufacturing errors, we can trace them, and then deviation from the specification, we can trace them, and that will gives us accountability related to the process, manufacturing process. Then there is the interoperability and integration. Transparent machines are designed to integrate seamlessly with other machines, systems, and software applications within the manufacturing environment. They support interoperability standards and protocols that enable data exchange and communication across heterogeneous devices and platforms. Let us say there is a CNC machine and there is a robot. They can communicate with each other, so that is the interoperability, and they are integrated with each other. So when the CNC machine completes its operation, robots will come and it will collect that particular product. So that is the interoperability. From which location it has to collect the product, it is specified. Where it has to drop the product, it is specified. How much time the CNC machine will take to create that particular product, it is specified. How much time the robot will take to carry that particular product from one place to another place, that is specified. So that is the interoperability and integration between these two things, and it is governed by some protocols that enable data exchange and communication across heterogeneous devices and platform. So heterogeneous devices means CNC machine is having a uh, different set of a communication pattern, and robots are having different set of communication pattern. They are connected with each other, so they are communicating with each other, so they are heterogeneous. Their platforms are heterogeneous, still they are communicating with each other, and they are transferring data with each other. So that is the interoperability and integration between these two devices. This interoperability allows for the creation of interconnected production systems that can share data, coordinate activities, and optimize workflows collaboratively. So predictive maintenance and optimization. Transparent machines leverage data analytics and predictive algorithms to anticipate maintenance needs and optimize performance proactively. By analyzing historical data, monitoring equipment health in a real time, and detecting early signs of potential issues, transparent machines enables predictive maintenance strategies that minimize downtime, reduce maintenance cost, and extend equipment lifespan. So further advantage of these transparent machines are predictive maintenance and optimization. When I say transparent machines, so they do data analytics, they do predictive, they run predictive algorithms, they anticipate maintenance needs and optimize performance proactively. So they are having a historical data. They monitor equipment health in a real time with the help of historical data. They detect early signs of potential issues. They show the transparent machines, the predictive maintenance strategies, how to maintain that particular machine, and how to minimize the downtime. They reduce the maintenance cost and extend equipment lifespan, and also it extend the equipment lifespan. Then there is the adaptability and flexibility. Transparent machines are designed to be adaptable and flexible to accommodate changing production requirements and configuration. So again, the transparent machines will helps adaptability and flexibility. So adaptability, whatever changes are there, they are adapted to those changes. So transparent machines are designed to be adaptable and flexible to accommodate changing production requirements or configuration. So whatever changes in the production, whatever the changes in the requirements, whatever changes in the configurations, these transparent machines are ready to uh, change or ready to adapt to that particular requirements and configuration. They support reconfigurable manufacturing processes, rapid setup and changeover. So further, these transparent machines support reconfigurable manufacturing processes. Whatever reconfigurations are there in the product design or process design, it will accept that, it will adapt to it, and whatever rapid setup and changeovers are there for the tools, it can do that. And dynamic scheduling adjustment, so whatever scheduling adjustments are there, they are adaptable for it, and flexibly it will do that. And they respond quickly to market demands on and unforeseen disruptions. So whatever market demands are there, changing market demands are there, they take those market demands, and whatever unforeseen disruptions are there, they are ready for that unforeseen disruption. So this adaptability enhance agility and responsiveness in the manufacturing environment. So enabling manufacturers to maintain competitiveness and adapt to evolve business needs. So when we say these transparent machines are adaptable, so they enhance agility. So whatever customer requirement, they are ready to fulfill that customer requirement, and they are very responsive. Whatever command is there or whatever requirement is there, they are responding to that requirement. So means they are very responsive in the manufacturing environment. So enabling manufacturers to maintain competitiveness and adapt to evolving business need. Whatever business need is there, whatever competencies is there with the other industry, that can be fulfilled with the help of these transparent machines. Then enhance collaboration and decision making. So transparent machine facilitate collaboration and decision making by providing stakeholder with access to real time production data and analytics. So the transparent machines are there. So they facilitate collaboration and decision making. So they collaborate. They facilitate collaboration between two sections of organization, and they can take a decision. So here the stakeholders are connected with the manufacturing organization. So the stakeholder can collaborate with the manufacturing organization, and this transparent machine provide real-time production data and analytics to the stakeholders. They can take decision based on that real-time production data and analytics, and they communicate it to the through the transparent machine to shop floor, and by that shop floor can fulfill their requirement. So in this way, the enhanced collaboration is there and decision making is also there. The stakeholder may be the management, stakeholder may be the operator, stakeholder may be the customer. These are the different stakeholder. They can have directly access to the production data and analytics. Based on that, they can take a decisions. So this is the enhanced collaboration and decision making through the transparent machines. So again, transparent machines enables cross-functional teams to collaborate more effectively, share insights and coordinate actions to optimize production performance. This collaborative approach fosters a culture of continuous improvement and innovation, driving operational excellence and value creation in digital manufacturing. So, this collaborative approach further foster a culture of continuous improvement. So, improvement is there, innovation is there, driving operational excellence and value creation in digital manufacturing. So, whatever steps are followed, they are with a quality, and there is a minimum wastage is there, and we can create value for each and every activity in a digital manufacturing with the help of transparent machines. So in a summary, transparent machines play a pivotal role in a digital manufacturing by enabling visibility, traceability, interoperability, and optimization across the production process. By leveraging advanced technologies and data-driven insights, transparent machines empower manufacturers to enhance efficiency, quality, and agility while driving innovation and competitiveness in today's dynamic manufacturing landscape. Then, as I have explained, interconnected objects in digital manufacturing. So, further, we are having some insights on the interconnected objects in a digital manufacturing for this digital communication. So in a digital manufacturing, interconnected objects refers to network devices, sensors and systems that are integrated into the manufacturing process to collect and exchange data, monitor operations and enable automation. These interconnected objects form the foundation of what is often referred to as the industrial Internet of Things within the manufacturing context. So here we can see how interconnected objects are utilized in digital manufacturing. So sensors and actuators. So interconnected object in digital manufacturing include sensors and actuators embedded within machines, equipment and production systems. These sensors capture various data points such as the temperature, pressure, vibration and machine status, while actuators enables machine to perform action based on the received commands. I have explained you there are the sensors and actuators, they communicate with each other. So that is nothing but we are using these interconnected objects for a communication purpose. They are communicating, they are executing the command. Then machine to machine communication. Interconnected objects enable seamless communication between the machines and systems on the factory floor. Machine to machine communication facilitates coordination between different manufacturing processes, equipment and production lines, allowing for a real-time data exchange and collaboration. So this is very important thing in a digital manufacturing. So a machine can communicate with other machine. It can transfer its data to the other machine. By that particular machine can perform its own operation based on the communication received from the previous machine. So this machine to machine communication can be possible in a digital manufacturing through interconnected object. So these machines are interconnected through some basic communication needs. Then data acquisition and monitoring. So interconnected objects collects and transmit data about the manufacturing process, equipment performance and product quality. So this data can include production metrics, equipment uptime, energy usage and environmental conditions. By monitoring these parameters in a real time, manufacturers can identify inefficiencies, diagnose problem and optimize production processes. So monitoring these parameters in a real time. So they are monitoring parameters in a real time. Manufacturers can identify inefficiencies, what are the inefficiencies are there. They can diagnose the problem and they can optimize the production processes. So data acquisition and monitoring is again play major role in the digital manufacturing. So as I explained, predictive maintenance. So interconnected objects enable predictive maintenance strategies by continuously monitoring equipment health and performance metrics. By analyzing data from sensors, embedded machinery, manufacturers can detect early signs of equipment degradation or failure, allowing for proactive maintenance to prevent unplanned downtime and costly repairs. So interconnected objects, the advantage of interconnected objects, it will allow us for a predictive maintenance. It will allow us for the strategies of predictive maintenance. By continuously monitoring equipment health and performance metrics, what we can do from the data received from the sensors embedded in machineries, the manufacturer can detect early signs of equipment degradation or failure. When the particular machine will degrade or fail, that can be identified with the help of data received from the sensor. So allowing a proactive maintenance to prevent unplanned downtime. So we can see the downtime and we can prevent that downtime with the help of predictive maintenance that can be done by interconnected objects. So and also we can prevent the costly repairs of the machines. So that can be done with the help of interconnected objects. Then there is a supply chain integration. We can achieve supply chain integration through interconnected objects. So interconnected objects facilitate integration with the broader supply chain ecosystem by providing visibility into inventory levels, material flow, and logistic operations. This enables manufacturer to optimize inventory management, track materials in real time, and coordinate production schedule with supplier and customer. Supply chain integration is also possible with the interconnected objects. So the supply chain ecosystem provides visibility For the inventory levels, material flow, and logistic operation, this further enable manufacturer to optimize the inventory, track the materials in real time, and coordinate production schedule with supplier and customers. Then quality control and assurance. We can achieve quality control and assurance with the help of interconnected objects. So interconnected objects plays a crucial role in the quality control and assurance by monitoring product parameters and detecting defects in the real time. So, by integrating sensors and inspection systems into the production process, manufacturers can identify quality issues early, reduce waste, and ensure compliance with the quality standards and regulation. So, quality control and assurance, when we say there is a interconnected objects, it will see the particular parameter. It will detect the defects in a real time. When we by integrating sensors and inspection system into production process, so manufacturers can identify quality issues early. So they can we can identify the specification of a particular product, whether they are accurate or not. We can see whether the uh, product is damaged or not. So by that we can reduce the waste. We can ensure the compliance with the quality standard and regulation. We can set some quality standard inside that particular machine, and we can check whether it is fulfilling the compliance with the quality standards and regulation or not. So that is again an advantage of interconnected object. Then automation and robotics. So interconnected objects enable automation and robotic solution in digital manufacturing environment. So by connecting robotic system, automated guided vehicles and other autonomous devices to the industrial internet of thing network, manufacturing manufacturers can streamline production workflows, increase productivity and improve safety. So here we can connect automation and robotics. So automation, that machines are working on their own, programmable machines. They are connected with robotics. So this can be achieved with the interconnected objects. So they enable automation and robotic solution in digital manufacturing environments. So by connecting robotic systems, so automated guided vehicles and other autonomous devices to the industrial internet of thing networks, so manufacturers can streamline production workflow. They can do the activities one after another. They can improve the productivity, and they can improve the safety. So that we can achieve with the interconnected object. Then data analytics and optimization. So interconnected objects generate vast amount of data that can be analyzed to gain the actionable insights and optimize manufacturing operations. By leveraging advanced analytics techniques such as machine learning and artificial intelligence, manufacturers can identify patterns, optimize process, and make data-driven decisions to enhance efficiency and competitiveness. So, with the help of data analytics and optimization, the interconnected objects they leverage various decisions through whatever data collected. They also helps in enhancing the efficiency and competitiveness in the market. So the overall interconnected objects play a central role in a digital manufacturing by enable data driven decision making, automation and optimization across the entire manufacturing value chain. So they empower manufacturers to achieve greater efficiency, flexibility and agility in response to evolving market demands. So we will go with this industry uses of interconnected object after 5 minutes of break. So we will connect with each other after 5 minutes. So after 5 minutes break. So let us have a break. let us start it again. So let's see. So we were at interconnected object. So now let us see what are the applications of interconnected objects. So industry uses of interconnected objects. So first, here is the list of real-time industry-specific uses of interconnected objects across various sectors. So first, the manufacturing industry. So what are the interconnected objects? So in a manufacturing industry, predictive maintenance of machinery and equipment to reduce downtime. So that is the use of interconnected object. Then real-time monitoring of production lines and optimization and efficiency. That is the second use of interconnected objects. Then inventory tracking and management to minimize stock out and overstocking. So that is the third use of interconnected object. Then quality control and assurance through continuous monitoring of product parameters. That is a fourth use of interconnected objects. Then supply chain integration for real-time visibility and coordination with supplier. That is the fifth use of interconnected object. So in a manufacturing industry, we can achieve this predictive maintenance, real-time monitoring, inventory tracking, quality control and assurance, and supply chain integration through interconnected objects. Then in healthcare industry, so remote patient monitoring for continuous health tracking and early intervention, smart medical devices for real-time monitoring of vital signs and health parameters, then asset tracking for medical equipment management and inventory optimization, then patient tracking and workflow management for improved hospital efficiency, medication management through smart pill dispensers and tracking systems. So these are the uses in the healthcare industry. So remote patient monitoring, smart medical devices, then asset tracking for medical equipment management, then patient tracking, and then medication management. So this we can do through the interconnected objects in the healthcare industry. So there are various uses of interconnected objects in various industries. So we will see one by one. The next industry uses of interconnected objects is transportation and logistic industry. So sorry, transportation and logistic industry. So fleet management for real-time tracking of vehicles and asset, route optimization to minimize fuel consumption and delivery times, cold chain monitoring for temperature sensitive shipments, predictive maintenance of vehicles and infrastructure to prevent breakdowns, supply chain visibility and transparency for better logistic planning. So these are the uses of interconnected objects. So fleet management, so for real-time tracking of vehicles and asset, route optimization to minimize the fuel consumption and delivery times, then cold chain monitoring for temperature sensitive shipments, and predictive maintenance of vehicles and infrastructure to prevent breakdowns, and then supply chain visibility and transparency for better logistic planning. So we can do all these things with the interconnected objects. So the route optimization is very basic thing. So we can optimize a route so to minimize the fuel consumption and delivery time. We can do cold chain monitoring for temperature sensitive shipment. What is the temperature, required temperature, what temperature we can maintain. Then predictive maintenance of vehicle and infrastructure. So what maintenance is required for that particular vehicle, we can provide that maintenance. Then supply chain visibility and transparency for better logistic planning. So then the fourth use is smart cities and infrastructure. Smart metering for real-time monitoring of utilities such as electricity, water, and gas. So, with the help of interconnected object, we can measure the utilities such as electricity, water, and gas for the smart city through smart metering. We can do a real-time monitoring. Based on that, we can charge some amount to particular consumption. Then traffic management and optimization for reducing congestion and improving safety. We can do traffic management. We can optimize the traffic for reducing congestion. We can change the routes of traffic and we can improve the safety with the help of interconnected object. Then environmental monitoring for air and quality, noise levels and waste management. We can do environment monitoring. So we can measure air quality, water quality, noise level, and we can have a waste management through the interconnected objects. Then public safety and emergency response. We can do public safety. We can receive emergency response through smart surveillance and sensor networks. So smart surveillance is smart surveillancing we can do with the help of interconnected object. We can see through CCTV cameras and we can work, we can take action on that particular activity. We can have a sensor networks. With the help of sensor networks, we can observe the particular activities and we can work on those activities. So then infrastructure monitoring for bridges, roads and buildings to detect structural issues. So we can do infrastructure monitoring for bridges, roads and buildings, and we can find the structural issues related with bridges, roads and buildings, and we can mitigate those effects for safety purpose. So that is infrastructure monitoring. Then industry uses of interconnected objects. So retail industry, how we can do, how we can use interconnected objects for a retail industry. The smart shelves and inventory management for real-time tracking of products. So we can have smart shelves where we can find whether a particular product is available or not. So by that we can order a new product so that we can do a inventory management for real-time tracking of products. Then we can do customer analytics and personalized marketing based on a real-time data insights. We can collect the data of a particular customer. We can do a personalized marketing. We can promote a particular product to a particular customer based on the real-time data. So that we can do in a retail industry. Then supply chain visibility. We can check supply chain for tracking shipments and optimizing inventory level. We can track shipments. We can optimize inventory levels. Point of sale system integrated with IoT for real-time transaction and inventory updates. So we can find a point of sale system. We can integrate it with the Internet of Things for real-time transaction and inventory updates. Then smart store environments with connected lighting, heating, and air conditioning system. So in a smart store, we can connect lighting. So as per requirement, we can do a lighting. We can do heating and air conditioning in the stores. So these are uses of interconnected objects. Then energy and utility industry. In energy and utility industry, so give a minute. So in energy and utility industry, a smart grid management for real-time monitoring and control of energy distribution. So we can do a smart grid management for real-time monitoring and control of energy distribution. We can demand response programs to optimize energy usage and reduce peak loads. So as per the peak loads, we can have a response to the energy demands. We can optimize energy usage inside organization. Then we can have asset monitoring and predictive maintenance of power plants and infrastructure. We can identify the assets. We can, we can monitor the assets. We can do the productive maintenance of power plants and its infrastructure. Then for renewable energy and integration and optimization for solar and wind farms. So we can use these particular interconnected objects for renewable energy. So for integration and optimization for solar and wind farms, we can do water management. Sorry. Management and conservation to enable sensors and control system. The water management, the which sector is required water, we can conserve the water through IoT enabled sensors and control system. Then in agriculture industry, so give me a minute. I will come back after a minute. अरे बाप So welcome back. So let's see further the use of interconnected objects in agriculture industry. Precision farming for real-time monitoring of soil moisture, temperature, and crop health. So we can do precision farming. We can do real-time monitoring of soil moisture, temperature, and crop health. So livestock monitoring for tracking animal behavior, health, and location. We can use interconnected objects. We can livestock monitoring is a monitoring of animal behavior. So the how animals are behaving in the field, their health, their location, we can track them with the help of interconnected objects. The irrigation management we can do for efficient water usage based on weather and soil condition. So as per the requirement of the weather and soil condition, we can supply water to the fields in order to enhance the productivity and enhance to optimize the water usage. We can work on the irrigation management. Then we can do a supply chain traceability for tracking the origin and quality of agriculture products. We can spot a particular location where the agriculture product is there. It's a previous step, it's a next step, and through which steps it comes to the market. We can track those things. That is a supply chain traceability. We can do a climate monitoring and prediction for early warning of extreme weather events. So that can be possible with the interconnected objects. The weather department will communicate with the actual field workers or on the actual field. So it can give warnings of extreme weather events. By that, we can take action and we can control on the damages occurred due to the climate. So these examples demonstrate the diverse range of application of interconnected objects across different industries, highlighting their potential to improve efficiency, productivity, and decision making in a real time. After this, let us see uh, industry uses of transparent machines. After observing industry uses of interconnected objects, let us see industry uses of transparent machines. So the transparent machines which provide visibility into their internal operations and decision making processes. It's have a wide range of real-time application across industries. So here is a list of industry specific uses of transparent machines. So manufacturing industry. So real-time monitoring of production processes and equipment to ensure quality and efficiency. That is the first use of transparent machines in the manufacturing industry. Then transparent predictive maintenance systems providing insights into machinery health and performance. Real-time visualization of supply chain operations, including material flow and inventory levels. Transparent control systems allowing operators to understand and adjust manufacturing parameters in a real time. So these are the uses of transparent machines in a manufacturing industry. Then in healthcare industry, transparent medical imaging system providing real-time visualization of internal body structure, real-time monitoring of patient vitals and health parameters with transparent monitoring devices. Then transparent decision support systems assisting healthcare providers with diagnosis and treatment recommendations. Then real-time tracking of medical equipment and assets with transparent asset management solution. So in the healthcare industry also the transparent machines plays a very important role. Then The industry uses of transparent machines in a financial service industry, transparent risk management system, providing real-time insights into financial markets, trends, and risk, real-time transaction monitoring for fraud detections and prevention in banking and payment systems, transparent algorithmic trading systems, allowing traders to understand and adjust trading strategies in a real time real-time visualization of financial data and performance metrics for portfolio management. So with the help of transparent machine in financial services, we can do transparent risk management so that risk we can identify and mitigate. We can do real-time transaction monitoring, how the transaction are happening on a real-time basis, transparent algorithmic trading. So we can do trading with the help of transparent machine. Then real-time visualization of financial data. We can visualize real-time transaction of financial data. Then retail industry, how we can use transparent machines in a retail industry. So transparent customer analytics system providing real-time insights into customer behavior and preferences, what customer preferred over other product, how it behaves for a particular product, that can be identified with the help of transparent machines. Real-time inventory management systems allowing retailers to track product availability and demand transparently. So real-time inventory management we can do with the help of transparent machines. Then transparent pricing and promotion system enabling retailers to adjust prices and promotions in a real time based on market condition. So transparent pricing we can do promotion systems, we can find a promotion systems to enable retailers to adjust prices and promotions in a real time based on market conditions. Then we can do real time visualization of sales data and performance metrics for store management. We can do real-time visualizations of sales data and performance metrics for store management. Let us go ahead with our transparent machine uses. So transparent machine uses in a logistic industry and in a transportation industry. So with the help of transparent machine, we can do transparent fleet management, providing real-time tracking of vehicles and shipments, real-time monitoring of transportation routes and traffic condition with transparent navigation systems. We can do transparent supply chain visibility solutions, allowing stakeholders to track the movement of goods in a real time. We can have a real time visualization of logistic data and performance metrics for supply chain management. So, this can be achieved with the transparent machines in the transportation and logistic industry. Then, energy and utilities industry. So, transparent energy management system providing real time insights into energy usage and consumption patterns, real-time monitoring of power generation and distribution networks with transparent grid management systems, transparent predictive maintenance systems for energy infrastructure including power plants and transmission lines. We can do real-time visualization of environmental data and sustainability metrics for energy and utilities management. So this we can achieve in the energy and utilities industries. Then use of transparent machine in smart cities and infrastructure. So transparent urban planning and management system providing real-time insights into city infrastructure and services. So real-time monitoring of traffic flow and congestion with transparent traffic management systems. Transparent emergency response system enabling real-time coordination and communication during crisis. So real-time visualization of urban data and performance metrics for city governance and decision making. So these are the examples that illustrate how transparent machines can be applied across the various industries to provide real-time insights, enhance decision making and improve operational efficiency. Then let us see real-time usage of digital manufacturing in industry. So digital manufacturing leverages advanced technologies to transform traditional manufacturing processes, enabling greater efficiency, flexibility, and agility. So real-time applications of digital manufacturing across various industries include smart factory operations. So in a smart factory operation, what we can do with the help of digital manufacturing? So real-time monitoring of production lines, equipment and processes to optimize efficiency and minimize downtime. So dynamic scheduling and adaptive manufacturing systems that responds in a real time to changes in demand, resource availability and production priorities. So we can do dynamic scheduling and adaptive manufacturing. So remote monitoring and control of manufacturing operations, enabling operators to adjust and troubleshoot issues in a real time from anywhere, that we can do in the digital manufacturing, uh, in the smart factory with the help of digital manufacturing. Then additive manufacturing, 3D printing, so real-time design and prototyping using digital modeling tools and 3D printing technologies, allowing for rapid iteration and customization. On-demand production of parts and components, enabling just-in-time manufacturing and reducing inventory costs. Real-time monitoring of 3D printers to ensure quality and reliability during the printing process. Then supply chain integration. So real-time visibility into supply chain operations, including inventory levels, supplier performance, and logistic movements to enable better coordination and decision making. So integration of digital manufacturing system with suppliers and partners for seamless collaboration and data exchange. So predictive analytics and demand forecasting to anticipate supply chain disruption and optimize inventory management in a real time. So then digital twin technology, creation of digital twins, virtual replicas of physical assets and processes to simulate and optimize manufacturing operations in a real time. continuous monitoring and analysis of data from digital twin to identify opportunities for improvement, predict maintenance needs, and optimize performance. So integration of digital twins with IoT sensors and analytics platform for comprehensive insights into manufacturing processes. Then the real-time usage of digital manufacturing in industry. So quality assurance and inspection, real-time inspection and quality control using advanced sensors, machine vision system and automated inspection technologies. Integration of quality data with manufacturing system to enable immediate corrective actions and prevent defects from propagating. Automated feedback loops between the inspection system and production processes to ensure consistent quality and compliance in a real time. So that can be achieved with the digital manufacturing in the industry. Then lean manufacturing and continuous improvement. So implementation of lean manufacturing principles supported by real-time data analytics to identify waste, improve efficiency and streamline operations. Deployment of continuous improvement initiative driven by real-time feedback and performance metrics enabling rapid iteration and optimization. So collaboration platform and digital tools for employee engagement and idea sharing to foster a culture of continuous improvement. Then product lifecycle management. So real-time collaboration of data sharing among cross-functional teams involves in a product design, development and manufacturing. So integration of product lifecycle management system with digital manufacturing tools to ensure seamless transition from design to production. Lifecycle tracking and version control of product design and documentation to maintain accuracy and compliance throughout the manufacturing processes. These real-time applications of digital manufacturing demonstrate its potential to revolutionize traditional manufacturing practices and drive innovation across industries. By leveraging advanced technologies and data-driven insights, organization can achieve greater efficiency, agility, and competitiveness in today's dynamic marketplace. So let us continue. So sorry for the break. So life cycle management. So we can achieve a life cycle, product life cycle management through digital manufacturing in a industry. So as I've explained, real-time collaboration and data sharing among cross-functional teams involved in product design, development, and manufacturing. So then we can do integration of PLM system with digital manufacturing tools to ensure seamless transition from design to production. Then we can do life cycle tracking and version control of product design and documentation to maintain accuracy and compliance throughout the manufacturing process. So in this way, we can achieve real-time applications of digital manufacturing, which demonstrates its potential to revolutionize traditional manufacturing practices and drive innovation across industries. So by leveraging advanced technologies and data-driven insights, organization can achieve greater efficiency, agility, and competitiveness in today's dynamic marketplace. So we have seen a real-time usage of uh, uh, interconnected objects. Then we have seen real-time uses of transparent machineries, and now we have seen the real-time uses of digital manufacturing in industries. So let us go ahead with the next point, that is a digital thread. So when I say digital thread, so digital thread is a communication medium which connect different uh, components of a digital manufacturing system. So digital thread is a concept used in a context of digital manufacturing and product lifecycle management. So it refers to seamless flow of digital information throughout the entire life cycle of the product. So when I say digital thread is communicating information, so we are having CAD, CAM, CAE, then we are having 3D printers. So the data from one point to another point, so it get communicated to a digital thread. So when we say there is a digital manufacturing occurring, so how it will occur? So it will occur through the digital thread. So the uniqueness of any product that can be identified with the help of digital thread. So means if I take a one product, so there is a particular digital thread aligned with that particular product. When I shift to a product, when I am manufacturing a different product, so then there is a specific digital thread assigned with that next product. So in this way, every product is having its unique digital thread, and it start communication from CAD model, CAD design till the product development. So that is the digital thread, and every product is having unique digital thread. So it goes throughout the life cycle of the product. Digital thread work throughout the life cycle of the product. So when we say there is a information transfer from one point to another point, so that can be done with the digital thread. So how this digital information or digital communication is happening within a different heterogeneous system, so that is with the help of digital thread. So here the digital thread connects various stages of product life cycle, so enabling data continuity, collaboration and insight across a different functional areas and stakeholders. So let us see the key components of digital thread. So that include product design and development. So digital models and simulation are used to design and prototype products, allowing engineers to create virtual representation of physical components and assemblies. These digital models capture product specification, requirements, and design intent, forming the foundation of the digital thread. So the product design and development. So when we say we are having a digital model or a simulation that can be used for design and prototyping of the products. So it will allows engineers to create virtual representation of physical components and assemblies. So these digital models capture product specification. So what dimensions products is having, what are the requirements of the product, so what are the design intent of the product, so forming and foundation. So this all information is captured through a digital thread, and digital thread communicate this information to the next step. Then engineering analysis and simulation. So when I say I am having a design of a particular product, so it starts a digital thread. So then the next step is the engineering analysis and simulation. So advanced simulation and analysis tools are used to evaluate product performance, validate design, and optimize engineering parameters. This includes finite element analysis, computational fluid dynamics, and other simulation techniques to assess structural integrity, thermal characteristics, and other key attributes. So when we say there is a engineering analysis and simulation, we take the design of a particular product, we analyze it through a different environment in a computational fluid dynamics. software or through FEA. We analyze various structural impact on that particular product. We analyze particular flow impact on that particular product. We simulate that particular product, and we can find the structural integrity, thermal characteristics, and other key attributes of that particular product. So the digital thread which we have created in the CAD, that is a design, that can be transferred to the different software, that is engineering analysis and simulation software, where we can identify the product features. Then there comes a manufacturing planning and execution. So digital manufacturing tools enables the translation of digital design data into manufacturing instructions and processes. This include computer aided manufacturing, computer numerical control programming, and additive manufacturing 3D printing technologies that convert digital design into physical product with precision and efficiency. Now I am having a digital thread with a design. So I have transferred it to the engineering analysis and simulation. I have characterized the features of that particular product. Then I am having a manufacturing planning and execution of that particular product. I want to create that particular product. How I can create that particular product? I can create it with the help of computer aided manufacturing. I can use the CNC machine. I can do a 3D printing for that particular product. So that will convert that particular digital design which comes as a digital thread into physical product with precision and accuracy. So this is the third step. Then quality assurance and inspection. So from the previous step of manufacturing planning and execution, we go to quality assurance and inspection. So the digital inspection and quality control methods are used to ensure product conformance and compliance with the specification. This includes automated inspection system, coordinate measuring machine, and statistical process control technique. So we are having a digital design with a specification, with a particular design features, design specifications. Now we have created that particular product with those specification. Now in the quality assurance and inspection phase, what we can do, we can again uh, go through the standards of that particular product, and we can check whether that specifications are as per the designs or not. So whether the final product is compliance with the standard or not. So that comes in a quality assurance and inspection. So this includes automated inspection system. We can observe the product specification. We can observe the dimensions, precision of dimensions, whether they are as per the design created or not. We can have a coordinate measuring machine. So with the help of coordinate measuring machine, we can identify the exact dimensions of the product. We can have a statistical process control technique. In the statistical process control technique, again we identify the defects in that particular product, and we can monitor product quality and detect defects during manufacturing. So the again the previous digital thread comes here in a quality assurance and inspection. It is communicating that data to the quality assurance and inspection thing. Then supply chain management. The digital thread extends to supply chain operations. Same digital thread comes in a supply chain operation, enabling real-time visibility and collaboration with suppliers, vendors, and partners. This includes digital supply chain performance, electronic data exchange, and supply relationship management systems that streamline procurement, logistic, and inventory management processes. Then the same digital thread comes in a service and maintenance. So digital information about product configuration, maintenance history, and service record is maintained throughout the product life cycle. This includes digital service manuals, remote monitoring system, and predictive maintenance algorithm that optimize product uptime, reliability, and life cycle cost. So service and maintenance is again a part of a digital thread. So after the supply chain management, the digital thread passes the information to service and maintenance. So digital information about product configuration, maintenance history and service records is maintained throughout the product life cycle. This include digital service manual. So what is a service manual? So how this particular machine works or how this product can be used. Remote monitoring system, what is the condition of that particular product. Predictive maintenance algorithm, so what is maintenance requirement of that particular product. Optimize product uptime, reliability and life cycle cost. These all things are recorded in the digital thread. Then end of life and sustainability, so that information is again contained in the digital thread. The digital thread encompasses consideration of product disposal, when to dispose the product, recycling, when to recycle the product, and end to life management. What is the end of that particular what is the life end of that particular product, that can be tracked through the digital thread. So this include digital traceability and environmental impact assessment to ensure responsible product stewardship and compliance with regulatory requirements. So whatever regulations are there, that whether the product is following those regulations or not, that can be observed with the digital thread. So in this way we can check all the life cycle of a particular product from design point to the end of life through a digital thread. So this is a communication medium across a various steps in the product development and in the product life cycle. So everywhere data get transferred through the digital thread. So design data get transferred to the that simulation data. Simulation data get transferred to manufacturing data. Manufacturing data get transferred to quality assurance and inspection. Quality assurance and inspection data get transferred to supply chain management. Supply chain management data get transferred to the service and maintenance step. Then from service and maintenance step, it will get communicated to the end of life and sustainability step. So by establishing a digital thread, organization can achieve greater visibility, traceability and control over the entire product life cycle. So this enables improved collaboration, decision making and innovation across the functional silos and stakeholders. So whatever functional silos are there, so means a department is not speaking with other department, or a department is not speaking with communicating with other department. That silos can be break down with the help of digital thread, as digital thread is automatically communicating from one point to another point in a manufacturing environment. So that is the advantage of digital thread. And again it enables improved collaboration, decision making and innovation across cross functional teams and stakeholders. So ultimately leading to faster time to market, higher product quality and enhanced customer satisfaction. Now the next thing is industrial internet of things for digital manufacturing. The industrial internet of things IIoT is revolutionizing digital manufacturing. Nowadays IoT is used everywhere, even in home appliances we are using IoT devices. The ACs we can control through our mobiles. AC we can control remotely. When we are outside our home, we can control our AC temperature. That is also possible. So these things are possible with the help of industrial internet of things. Sensors are there. With the advanced sensor technology, we can monitor the equipments and we can control the equipments. So this industrial internet of things is revolutionizing the digital manufacturing. So similarly in manufacturing industry, with the help of industrial internet of things, we can control machineries, we can control the product manufacturing, we can control the standard of a product manufacturing. So that is a possible. So by connecting industrial machines, devices and sensors to the internet, enabling data collection, analysis, and automation to optimize manufacturing processes. Here are some ways of industrial Internet of Things is transforming digital manufacturing. So first is a smart manufacturing. So industrial Internet of Things enables the creation of smart factories where machines and equipment are interconnected and communicate with each other in a real time. What is a smart factory? Smart means the machines are communicating with each other through various devices. So the basic device is a sensor device which enable a machine to transfer its information to the other in machines. So that is possible through the industrial Internet of Things. So equipments are interconnected and communicate with each other in real time. They transfer data from one point to another point. What activity can be performed after this activity? So they can communicate with each other and they can perform those activities. So this connectivity allows for seamless integration of production system, enabling manufacturers to monitor and control operations remotely and in a centralized manner. So then the next thing is a predictive maintenance. So industrial Internet of Things sensors can collect data on machine health and performance metrics such as temperature, vibration, and energy consumption. So as we know, the condition monitoring system basically depend on vibration measurement. When we are having vibration measurement equipment with the help of frequency analysis, I can tell whether the fatigue level of that machine is achieved, whether that machine require maintenance, whether that machine require repair. That can be identified with the help of IIoT sensors. What amount of energy this machine is consuming, that can be identified with this IIoT sensors. Where the various parameter we can track with the help of IIoT sensors. So by analyzing this data using machine learning algorithm, manufacturers can predict equipment failures, whether the equipment is uh, now in the condition of failure, we can identify that, and before they failure occur, so what we can do, we can plan a preventive maintenance, or we can arrange a new machine at the place of the same machine. We can minimize the downtime and we can reduce the cost of the operation. So we can do these things with the industrial Internet of Things. Then quality control and process optimization. Industrial Internet of Things enables real-time monitoring of manufacturing processes and product quality. Sensors enabled in production equipment can detect defects or variations in a product characteristics, allowing manufacturers to make immediate adjustment to maintain quality standards and optimize production efficiency. So with the help of IIoT sensors, we can monitor the quality of that particular process. We can optimize the quality of that particular process, and we can achieve variations in product characteristics, allowing manufacturer to make immediate adjustment to maintain quality standards and optimize production efficiency. So again, there are benefits of industrial Internet of Things. Then supply chain visibility. So where is the particular product by tracking inventory levels, shipments, and production schedules in real time? Manufacturers can optimize inventory management, reduce lead time, and improve coordination with suppliers and logistic partners. So this industrial Internet of Things means the sensors mounted at different stages gives information about the product flow, inventory flow, to the different stakeholders, that is manufacturer, to the supplier, to the customer. So by that we can optimize our supply chain, we can visualize the stages which through this product is going. through from the shop floor to the market. So that can be done with the help of industrial Internet of Things. Then energy management. So industrial Internet of Things enables energy monitoring and optimization by tracking energy consumption at the equipment level and identifying opportunities for efficiency improvement. So with the help of sensors, what we can do at a different manufacturing stages, what is the energy consumption? We can track that energy consumption and we can try to minimize that energy consumption at that particular stage. We can track overall energy consumption throughout the processes and we can try to minimize that energy consumption by monitoring that energy consumption. So that can be done with the industrial Internet of Things. Then manufacturers can implement energy saving measures such as a load balancing, equipment scheduling, and predictive maintenance to reduce energy cost and environmental impact. So that can be done with the industrial Internet of Things. Then remote monitoring and control. So industrial Internet of Things enables remote monitoring and control of manufacturing operation. So with the help of industrial Internet of Things, what we can do, so we are at a home and we can observe the manufacturing operation in on the shop floor. We can control that operation from anywhere with the internet connection. So internet, with the help of internet, we can get connected with the manufacturing operation. We can check whether the operations is occurring as per the requirement or not. If it is not, then we can change that operation. So these capabilities allows manufacturers to access real-time data, troubleshoot issues, and adjust production processes remotely, improving responsiveness and agility. So whatever customer requirement that can be captured and that can be implemented on the manufacturer environment, and by that we can improve the process and also the product quality we can improve with the help of industrial Internet of Things. Then customization and personalization. The industrial Internet of Things facilitate mass customization. So when I required a particular customized product in a mass, I can produce that. And personalized manufacturing. So when a particular customer is having a different requirements as compared to other customer, that personalization can be done with the help of information collected from the customer, and we can give preference to a particular customer with the particular product specification, and we can manufacture in through it digital we can manufacture it through digital manufacturing, and we can provide that particular product to the customer. So manufacturers can use this data to customize products on demand, optimize production schedules, and deliver personalized products to market faster and more efficiently. So then data analytics and insight. So industrial Internet of Things generates vast amount of data that can be analyzed to gain insights into manufacturing operation, identify patterns and make data driven decision making. So advanced analytics tools can uncover hidden correlations, optimize production parameters and drive continuous improvement in manufacturing processes. The industrial Internet of Things basically they are creating data at each and every step in the manufacturing operations. So the data collected will help in a various manner. So we can have insights into manufacturing operation. That is the first thing. We can identify the patterns of the product. That is the second thing, and we can make decision as per that particular information. That is the third thing. So the advanced analytics tools, so we can use to uncover the hidden correlations. So what is the relationship between two subsequent operations? How a first operation is affecting the second operation? So that can be observed with the advanced analytics. So optimize production parameters. We can optimize the production parameters, and we can drive continuous improvement in a manufacturing processes. That can be done with the help of industrial Internet of Things. Then cyber security. With the increased connectivity comes the need for robust cyber security. So as I have explained, the digital thread is again a data, and the data should be secure. When I am creating a particular thing with a specification in my organization, that can be prevented from theft, that is our responsibility. So with increased connectivity comes the need for robust cyber security measures to protect against the cyber threats and ensure the integrity and confidentiality of the data. So whatever data I have created through a manufacturing process, that should be kept very secure in my organization only. So that is the responsibility, and that can be achieved with the cyber security. Manufacturers must implement cyber security best practices such as encryption, authentication, and access control to safeguard their industrial Internet of Things infrastructure and data. Whatever we are creating digitally, that should be encrypted, authenticated, and we should have access control on access of that data. So that will safeguard this industrial Internet of Thing infrastructure and data. So overall, the industrial Internet of Things is transforming digital manufacturing by enabling greater connectivity, efficiency, and agility, and empowering manufacturers to drive innovation, improve quality, and stay competitive in an increasingly digital and interconnected world. So I think this is sufficient for today. So in the next class, we will see industrial Internet of Things components for digital manufacturing. How we can achieve industrial Internet of Things in an organization. So that we will see in our next class. So I will stop recording here.